Sir, can you listen to me? Hello?
Yes, you are audible. Start.
Okay, sir. Sir, I will start presenting. Just give me 2 minutes. I will start presenting. Okay, sir.
Yes, you start, please.
Okay, sir. Sir, is the slides visible? Hello?
Slides are not now visible.
Is the slides visible?
Now slides are visible.
Okay, sir. Okay. A very good morning to the chair professors and to Jalpaiguri Government Engineering College, my alma mater. I had passed out from this college in 1996. And after that, I did my MTech PhD. And right now, I'm working as an associate professor in Elite College. So today's my paper title is Numerical Investigation on MHD Conjugate Heat Transfer in a Nanofluid Field Corrugated Porous Rhombic Enclosure. My paper number is 1542. So the contents of my PPT is like this: introduction, literature survey, methodology, results and discussions, conclusion, summary, future scope, and the references. So introduction. So lateral convection still continues to be accounted investigation and has actually been utilized in several studies regarding the porous padding design, the solar receptacle technology, where radiation is also a primary way of dealing the studies, the printed electronic circuit board in electronics, and in several distinctive practical applications ranging from geophysics to civil engineering to fire and whatnot. Okay. So in this regard, Betas had examined the conjugate natural convection inside a regular square enclosure saturated with porous media. Chang and Lin had examined the effects of the natural convection heat transfer conducting all in a rectangular cavity, means a rectangular enclosure saturated with a non-Darcian porous media. This is one way of solving the porous media fluid. So it is a non-Darcian porous media fluid. San and Pop studied natural convection inside a porous triangular enclosure, which was being heated by a wall heater, flush-mounted heater, and was just saturated with nanofluids. He had used 3 different nanofluids in his study. Chamka and Ismail had examined conjugate heat transfer in enclosure, considering porous and simultaneously saturated with nanofluids, in which was subjected to heating by a triangular thick wall, right? Triangular enclosure subjected to bottom wall corrugated wall was examined by Rahman et al. Wall. Rahman also studied the aftermath of corrugated frequency and the material convection heat transfer utilizing nanofluids, finite element method. So as for knowledge and belief, investigation of conjugate natural convection heat transfer pertaining to nanofluids in a porous rhombic enclosure with differential heating and MHD. So there was a lot of complications in this study. So not only the enclosure is with subjected to is saturated with nanofluids, but it is also a it is actually a porous enclosure. Also, it is having a thick wall. So it is a assumption of one wall has been considered to be a thick. other walls have been considered to be no, there is no thickness on considering the other walls. So it is an assumption actually basically, but it is also it is subjected to differential heating, and simultaneously the MHD has been also been applied on along the cold wall. So this makes the problem a bit complicated. The rhombic enclosure inclination has been chosen to be 60 degree, and accordingly we have solve for the streamlines, isotherms, local and average Nusselt number by using COMSOL finite element analysis software. So this is the enclosure which looks like, so porous enclosure. So this is the solid wall. It is the thermal conductivity of the solid wall is considered to be 1. The TH is at higher temperature, TC is to be at lower temperature. This is a applied magnetic field along the cold wall. The rest walls, the top and bottom walls are considered to be adiabatic. Okay, and this thickness of the solid wall has been varied from 0.25 to 0.5. So there is in two types of thickness of the wall that is varied because of the constraints of the this particular conference paper. So all other things means the copper water nanofluid being assumed incompressible. There is this is a Newtonian fluid, and the porous portions of this mathematical was solved by the Darcy-Brinkman's model, and accordingly we have chosen the thermal conductivity to be also to be as 1. And this is the wall, the left right sorry the right wall is actually given a wavy structure, and this is the equation of the right wall. So this is the an by n, which is the amplitude, and L is the length of this length. Okay, the dimensional wave amplitude a by n. Okay, it is fixed as 0.05, and also the undulation parameter also it has been kept as 5, right? So the Boussinescu's approximation is given in the momentum equations, and this is the governing equations. The saturated nanofluid, copper water nanofluid, it is saturated by copper water nanofluid, obeys Newtonian laws. The two-dimensional nanofluid, as I said already, it is non-compressible, and also the thermal dispersion model, single-phase nanofluid model adopted from Zuan and Rotzel. The velocity slip and a Brownian and thermophoresis is neglected, and this is the governing equation. So this is the mass, momentum, and the energy equation. So this is the energy equation pertaining to the solid left wall, and this is, while considering this equation, this is a dimensionless equation. So accordingly we have chosen Ra, Da, Ha and Prandtl number, which is actually the main governing numbers for this natural convection study. Okay, and so the continuing from the previous slide, UNF and BNF is the density and coefficient of the thermal expansion, while alpha NF is the thermal diffusivity of the nanofluid respectively. And this is adopted from, as I said, Juan van Rotzel. So this is the thermal, the effective dynamic viscosity and the thermal conductivity of the nanofluid was modeled using the Brinkman's model. So this is the mu NF and KNF. And F and P here denotes the base fluid and a nanofluid respectively. And this is the boundary conditions adopted accordingly, as I said. So this is the boundary conditions TH and TC. So this is the boundary conditions which is adopted from this to solve. So along the left wall it is 1. So along the right wall it is 0, and along the other edges it is so it is actually there is adiabatics. So n is labeled as direction normal to the rhombic enclosure ambit, right? So for all the other thermophysical properties are taken from this table: density, specific heat capacity, thermal conductivity, dynamic viscosity, thermal expansion, beta. So now the validation. So validation actually was carried out. Two validations was done. One was for actually why we did two validations, because one was validation was for the this type of geometry enclosure, because of this it is a porous as well as thermofluid. So accordingly we have chosen one study from Sun and Pop. So the validation was an average Nusselt number obtained for the present investigation by Sun and Pop. So according to the different volume fractions that you see, these are different RA numbers. Okay, so we can see that this is according to the modified Rayleigh numbers. We have seen the present work is more or less very similar. It is less than 2%. So less than 4%. Only one is exceeding 3.3. So most of the results are less than 2%. So it is actually means the COMSOL results are quite, it can be proceeded with. Okay, And there is another validation we did from the regarding for, because it is a conjugate heat transfer problem. So we adapted from the study of Ismail. So Ismail ETL 2016 paper. So this is the diameter, the length of that particular wall, 0 0.5, 0 0.5, 0 0.9, 0 0.9. Accordingly, this is the thermal conductivity ratio we have chosen. And we see that our results are very much similar with that of Ismail. So accordingly, we proceeded with the results and discussion. We had also carried out the grid independency or the correlation on the average Nusselt number on the left wall for distinctive grid systems for two types of volume fractions. So we have here we have done for one volume fraction, Darcy 10 to the power -2 for rhombic enclosure 560. So accordingly, we have chosen with 16,956 finite elements. And this is the streamline. So you see, it is here we have only shown some results and discussions, streamlines and isotherms for RA 10 to the power 6, Prandtl number 6.6, HA0, D, this is the thickness of the wall, D is 0.2, thermal conductivity ratio 1, HA0, and Darcy is chosen as 1. Okay, and this is for 10 to the power 6, and this is for HA100. So accordingly, when the value of this magnetic influence is greater, the values are actually, it is subset, it is actually decreasing. You can see this is the 187, and now it has reduced to 13.136. So obviously, the presence of this magnetic has reduced the streamline intensity to around more than it is a huge, so around more than 90%. So this is the streamlines also. So streamlines are, it was previously, it was twisted, now they have become more flat like because of the presence of lesser convection. And this is according, there is another one that we have chosen here. This is for thickness, we have increased to D 0.5. The conductivity ratio was 1, and the HA0 was actually maintained constant. So you have only short for HA0, and this is for accordingly we have chosen for HA0 and Darcy to the power 0.5, and this is we can see that the values are also quite lesser. Okay, so this is 10 to the power 3, and this is for 10 to the power 6. So this is manifesting the presence of convection in the enclosure, because with increase of the Rayleigh number, we see the buoyancy forces, now convection is from 1.328, it is actually increasing to 212. In the, this is the sign convention, minus sign convention means the clockwise convention. Okay, so it is moving in the clockwise fashion. And this is the Nusselt numbers. So this is the local Nusselt numbers. This is the left wall local Nusselt number, profile of local Nusselt number for left heated wall and right undulated wall for various Nusselt numbers. The thickness is D 0.2. Kr is equal to 1. The thermal conductivity 10 to the power 3 and 10 to the power 6. So we have plotted for this, and also they have chosen for 10 to the power 3 and 10 to the power 6 for HA100. So accordingly, we can see the values are much lesser for this. When we are reducing, when so we are intensifying the value of this HA. So HA has a detrimental effect on the heat transfer. And this is the comparison of average Nusselt number for left for hot wall and cold right wall for volume fraction. Two volume fractions, so points means 2.5% and 5%. So Darcy has been chosen as 1, D is 0.2 and H is 0. So left heated wall, this is the values, and cold right wall, the values are lesser. Okay, and this is another Nusselt number results. So comparison for left wall and right wall for volume fraction 0.05, to showing clearly that as we give the nanofluids influence has resulted in the intensification of the this convection, and also we can see manifestation of larger values of average Nusselt number when we move from the base fluid. So this is the base fluid condition, and we have now increased the nanofluid percentage from 0.00 to 0.25, 2.5, and this is 5%. So it is intensifying. It is a clear manifestation that with the help when we are in giving the nanofluids, there is a intensification of heat transfer. And this is the conclusion. So in this research paper, a lot of things was is done. Numerical analysis of conjugate natural compound. Not only it was a porous rhombic enclosure, it was saturated with copper water nanofluid. Heated, it is also having a conjugate, since the heated left wall is the thickness of the wall was considered. and the Rayleigh numbers was actually solved for 10 to the power 3 to 10 to the power 6. Dimensional wall thickness was varied from 0.2 to 0.5. Hartmann number, according to the magnetic influence number, has also varied from 0 to 100. Nanofluid volume fraction was varied from 0 to 5%. So the final results depict that when the left wall thickness increase, the heat convection mechanism does changes to conduction. Okay. And furthermore, the volume fraction intensification. So one by one we have done. So we have showed that the volume fraction intensification result in a local Nusselt number has increased. And while interestingly at 10 to the power 5, there was a reverse behavior shown for NU along the heated left wall and cold right wall. So this is an interesting way at that RA number, Rayleigh number. So NU is more for 0.25 lesser than 0.5. Okay, the future scope of the work will be considered for different non-uniform enclosure design with the effects of porosity. So porosity have not considered here, and also the single phase nanofluid was considered. We could for two phase nanofluids will consider. So this is my presentation. Thank you so much, sir.
Thank you, Shantanu.
Thank you, sir.
Thank you. Is there anyone to ask some questions? Any doubts? Anyone have any question? Oh, no question is there. I have one. I want to ask some question.
Yes,
one is,
yes, sir.
What would be the application? You
So
can specify.
Yes, sir. Actually, sir, you see, this is this type of enclosure is applicable for PCB, electronic circuit design, and we can see that a lot of work is done on rhombic enclosure. So rhombic enclosure, we can, if the actually the study is limited only for natural convection, obviously we can use this type of enclosure studies in the printed circuit board design. Also, you can see a lot of research work has been done by Tanmay and Basak. Tanmay Basak has done a lot of work is from in this type of enclosure design. So it is not only that we have chosen for one Prandtl number of type of fluid. So obviously we can vary the Prandtl number of the fluid, and accordingly, if the enclosure design is chosen as rhombic, so you can obviously use this type of enclosure design in different types of chemical applications. We can use it in printed circuit board applications. We can use it in medical diagnostics also, where this type of enclosure designs can give us an idea of where heat transfer intensification is occurring and where intensification is not happening. So this is a rough idea. So obviously we can go with that type of designs.
And what would be the accuracy?
Accuracy, so obviously, sir, this is the accuracy means we have done the validation. Obviously, it is a numerical study. Okay.
Can you show the validation?
Yes,
Can
sir.
you show your validation?
100%. Please. Yes, I am showing the validation. So there was two validations, and also the grid independence is also important, sir. So this is the you can see find that there was two validations I have done. Why I did two validations? Because one was this is a problem involving conjugate natural convection, and as well as Darcy number is there, which is a porous as well as nanofluid. So obviously Sun and if you see the Sun and Pop paper, I have put it in the references. Sun and Pop paper is not considering the conduction of the wall. Okay, so it is a thickness of the wall is not there. So accordingly, we have done one validation without considering the thickness of the wall. So this is, however, this is having the Darcy number and as well as having the presence of the nanofluid. So this is nanofluid percentage, you can see. So this was one validation, and you can see that the results are very, very less. So the means the accuracy means it is less than 4%. Even in the, if you see for the other values for RA number 500, 100, sorry, 1000, you can see that as the volume fraction is increasing, the accuracy is even greater. It is less than even 2%. So this is obviously if the so as for the literature survey, if the validation is less than 5% in any standard international journal, you can see, sir, you already know. So obviously it is always accepted. And also another validation was this was for the thermal conductive. So this was a conjugate case. Okay, you can see 23.8 for the brick wall. Okay, so brick wall is having a conductivity ratio of 23.8. So accordingly, this also validation is, you can see that the results 1.56, 1.5. So it is very, very similar. Okay. And always
Mhm.
we do for a grid independency test. Also, always before we do any numerical study, as it is not an experimental study, it is always recommended to do a grid independency study because the results must be independent of the grid. Okay, you can see from there also it is independent of the grid. We have chosen 16,956 to be the grid elements. So according to that procedure, because it is saving the time as well as the money. So when you are doing a huge amount of computational work, obviously you have to think like that, sir. Okay.
Okay, okay. Is there any practical applications in the thing, practical work has done on like
No, sir.
experimental work on that? Any
Experimental
experimental
work.
work on that?
As for my information, only Tanmay Basak sir of IIT Madras has done, I think, as for my
Okay,
information. Because
okay,
this
okay,
type
okay.
of application is with this type of complexity, means with considering porous as well as this nanofluid as well as magnetic influence, it is difficult to actually make a physical model. Obviously, I am not saying no. Obviously, it can be done, but with limited facilities in private colleges, obviously, sir, obviously
Okay,
national
okay.
and this
It's
type
okay.
of thing. So obviously we could have done. I have always I'm willing to go for some this type of experimental work. Okay, sir. Thank you.
Where are you now?
Sir, right now, sir, actually after finishing my PhD, I'm working in a elite college. So that college is actually the owner is also the alumnus of Jalpaiguri Government Engineering College. The owner is also the alumni of the Jalpaiguri Government Engineering College. He passed out in 1992. So I'm working in elite college right now. I am actually looking for some postdoctoral work from outside India. Let me see, sir. In the future, I will definitely means I'm trying for some good jobs. Thank you,
Okay,
sir.
okay. It's okay. It's okay.
Thank
Now,
you.
you must stay on our valedictory session.
Yes, sir.
The announcement of the awards at that time.
Okay,
Okay.
okay, sir. I will do,
Thank
sir.
you. Thank you very much.
Thank you,
Thank you
sir.
for the day.
Thank you, sir. Thank you. Thank you.
Next, 1547. Ashok Devangan.
Yes, sir, I'm available.
Okay, sir. Please start your presentation.
Okay. So now the slide is visible.
Yes, yes, yes.
Uh,
All is okay. Start.
okay. Very good morning to all. This is Dr. Kumar Devangan. I'm working at NIT Delhi. And today I'm going to present on this topic, boiling behavior of isobutane on a horizontal plane tube. So when we go for this introduction, so as we know that the phenomena of heat transfer is encountered in engineering system and other aspect of life. And the cooling aspect is one of the great importance to engineering application. Because of the failure of proper cooling of devices and materials, that can lead to improper operation or material degradation and subsequent failure. So according to this table, we can see that this boiling is an efficient method due to its profound ability of boiling liquid to achieve high heat flux with a minimum temperature difference. And when we get this minimum temperature difference, so definitely we will get the maximum heat transfer coefficients. So this one is the simple typical pool boiling curves. uh, so here, as we know that the bubble do not form on the heating surface until the liquid is heated a few degrees above the saturation temperature of the liquid, and which is slightly superheated in this case. The fluid motion in this mode, suppose here this 0 and 0 to A. So in this mode, it is governed by the natural convection current. And heat transfer from the heating surface to the fluid is only due to this natural convection. And when we go for this region, so this A to C, basically this region is known as the nucleate boiling regions. And when we go for this A to B region, so in that case, The string and agitation, this phenomena, due to this phenomena, causes by this entrainment of the liquid to the heater surface is primarily responsible for the increased heat transfer coefficient. In this reason, the large heat flux obtainable are caused by the combined effect of the liquid entrainment and evaporation. After this point B, the heat flux increases at a lower rate with increasing the this delta values, and it reaches the maximum point. That point is known as a critical points, which is the prime injury importance. But in case of this boiling, here only we are studying between this region 0 to here this up to this C, and in case of this boiling we will consider only this nuclear boiling regions. So nuclear pool boiling phenomena has a immense heat transfer application due to the ability to remove enormous quantity of heat from the heating surface with a limited temperature difference. Basically, this suggests a reduced size of the heat exchanger by improving the efficiency of equipment used in many industries, such as the refrigeration and air conditioning industry, thermal power plant, process industry, and many other industry. So, in this type of industry, the one component is used. That component is known as the flooded evaporator. This flooded evaporator is widely used as a heat exchanger in refrigeration and air conditioning industry. So in this type of equipment, refrigerant boils on the outer surface of the tube. So now, when we choose this boiling phenomena, so there are different heating methods available. So one heating method is a heat flux control method. Another method is a wall temperature control method. But when we do the experiment, the controlling of this temperature on the surface, it is a very difficult. And we can easily control this heat flux by using these some instruments like as a power variacs. So during this boiling phenomena, here I'm trying to control this heat flux as compared to these temperatures. And when we choose this nuclear boiling phenomena, so there are different heat transfer mechanism is act. So in case of this bubble agitation, the pumping motion of growing and departing bubble agitates the liquid and pushing it back and forth across the heating surface. This induced phenomena is known as a intense convection. Hence, the natural convection process is transferred into a forced convection process. And the superheated liquid that is moved, the superheated liquid that is moved from the heating surface as a sensible heat and influenced by the supplied heat flux. But in case of this vapor liquid heat exchange phenomena, the transient conduction occur from the heating surface to the liquid, and a superheated liquid layer from forms on the surface. The superheated heated liquid layer is removed from the boiling surface or this heating surface due to the formation of these wakes, which is creating a cyclic thermal boundary layer. But in this case, the sensible heat is transported away in the form of superheated liquid, and which depends upon the layer thickness, average temperature, the area of the boundary layer that is removed by the departing bubble, and the bubble departure frequency and nucleation site density. And the next big process is this one is the in the evaporation mechanism. Here the heat is conducted to the bubble interface through the thermal boundary layer. And here this, the heat transfer at this top of this bubble is termed as a macro evaporation. Occurs across the liquid layer trapped between the bubble and the interface, the surface. In that case, the latent heat transfer rate depends on the discharge of the vapor away from this heating surface per unit area. When we go for the selection of this refrigerant, we already know that this boiling phenomena basically it depends upon the depends upon the surface modification and the fluid condition. So most of these flooded evaporator are typically designed for the use of these many of these chlorofluorocarbons and hydrochlorofluorocarbons. But however, concern over the environmental impact such as ozone depletion and also global warming has resulted in an international commitment to discontinue the use of these chlorofluorocarbons and hydrochlorofluorocarbons in most of the refrigeration application. So hence, this environmental concern over this use of these chlorofluorocarbons and hydrochlorofluorocarbons refrigerant in the refrigeration and air conditioning industries has led to the development of these new alternative refrigerants. So now in this study, we have chosen this new alternative refrigerant, such as that is a pure refrigerant R600A, that is known as the isobutane refrigerant. So for performing of this boiling phenomena, this is our photographic view of this our experimental setup, and this one is a schematic diagram of this. So here this test apparatus basically it's composed of this cylindrical test vessel. So this one is the cylindrical test vessels and condensing loop. So here this condensing loop inside this condenser, inside this boiling vessel, there will be the internal condenser, and there will be some power supply arrangement. So in that case, this cylindrical or boiling vessels has a 150 mm diameter. So in order to observe this boiling phenomena, there will be some observation window or inspection window on opposite side were installed in the vessel. And the tube is made of here we are chosen these copper tubes where its diameter is a 25.4 mm and its effective length is a 116 mm, which is fitted with a stainless steel flange at one end of these vessels. Basically, this tube, this test section or this tube is heated by a cartridge heater with an actual heated length is a 116 mm and its diameter is a 16.6 mm. That is inserted inside these horizontal tubes. And this cottage heater basically it's a maximum power supply that was the 900 watt, which produce a uniform heat flux on the surface of the heat transfer tubes. And this condensing loop basically consists of this internal condenser, and there is some water pump and a cool water bath. So an internal condenser, this one is made from the copper tube, and that is was used for the condensation of vapor formed during the boiling of this refrigerant inside these vessels. And this refrigerant vapor boil off from the test tube and comes into contact with this condenser, this outer surface of this condenser and gets condensed. And here this some external chiller with an accurate temperature controller was also used to condense the vapor and at the same time to maintain the pool boiling temperature, a pool temperature to 12 degrees centigrade. And here the some auxiliary heater is also be mounted below this horizontal tube in the vessel for controlling the pressure of the system. And this system here, this vessel is a well insulated with glass wool from outside to ensure the adiabatic conditions. And now here, this one is the photographic view of the experimental facility with the some camera arrangement is shown here. Here the boiling visualization examination with the transparent side glass or this observation window of the test section show a particular liquid vapor exchange phenomena occur during this boiling. And here this camera was used to record this bubble phenomena. And for the stability and alignment purpose, here we use this some tripod which provide this stability and alignment for this our that is basically supported to this camera. And this camera can capture a maximum of 1000 frame per second of full resolution with a shutter speed of 1 by 9600 seconds. And now here the some lens is also used to magnify the area of interest and work at close distance from this surface. So now in that case, when we go, we'll discuss about this some results. So now here only we use the some simple natural convection heat transfer equation for calculating the heat transfer coefficients. So as you know, the Q is equals to H delta. Now here this Q is the heat flux, and the properties of this refrigerant I have chosen from this reprop. It's with the temperature 12 degrees centigrade. So according to this, all these properties given. So when we do the experiment, so the first thing is that how will you validate your setup? So in order to establish the integrity of our experimental setup and the verify the temperature measurement in this present test arrangement, so some preliminary tests have been conducted with this refrigerant. The heat transfer results of this pool boiling of refrigerant over this horizontal tube are compared with the some conventional correlations. So here this experimental result shows plus minus it's around 17% error for this refrigerant with mean deviation ranging from this minus 15.87 to 16.45. Among this correlation, the deviation is smallest by using this Stefan correlations and Cooper correlation for this refrigerant. And this result obtained from this present work that it basically shows the uh, good agreement with the predicted result, and consequently this setup is reliable for a given operating condition and the temperature measurement. And now here the variation of this heat transfer coefficient with the wall superheat were observed here. This may be due to the variation of the size of the bubbles. Generally, it offers the thermal resistance at a high wall superheat. And this effect that can be shown due to this variation of this heat transfer coefficient at a particular wall superheat. The lower amount of the superheat is required for this refrigerant. That's why we get the higher heat transfer coefficient. And now when we go for this some photographs which capture by this high speed camera to visualize the boiling behavior on this surface. So this visualization were used to obtain the bubble characteristics for a given heat flux range. So they captures high speed images of this bubble behavior were analyzed with this images software. And this analysis enabled to obtain the bubble parameters like nucleation site density, bubble departure diameter, bubble frequency, that is of plane surface. So for that purpose, the images are captured for the different heat flux. And here this figure basically detects the individual and merged bubbles resides in pool boiling of refrigerant. As the heat flux is increases from 10 to 50 kilowatt per meter square, the bubbles merge to each other and form a large bubble on the surface. These bubbles are continuously escaping to the liquid pool. At low heat flux condition, it's around 10 kilowatt per meter square. The bubble forms at a certain parts of the surface, and the sides are nucleated over the whole surface. And the more bubbles are activated, or more number of active sites are visualized as the level of heat flux is increasing. So the initial bubble size on the top surface are larger than those on the side surface. The growing of this bubble initiate from this bottom surface and merge to each other, and this merging bubble slide along the side of this surface and departure from the top surface. So as a result, here this some large departure diameter we can observe for this R600A. So now when we go for the some bubble dynamics or some bubble parameters, so there are three bubble parameters are observed here: nucleation site density, bubble departure diameter, and bubble departure frequency. So this generation of this active site density on the surface basically is dependent upon the applied heat input and the condition of the surface. The trends of this curve basically it is a quite similar to this conventional correlation, that is the Joubert models. This this deviation was observed between this experimental and predicted result due to the differences operating and surface condition and the type of the fluid used. And this results reveals that more bubble form on the surface as increase the heat flux. So this occurred because the larger size cavity present in the surface get activated with the heat flux increases, and more small size of the bubble is nucleated on the heating surface at the low heat flux condition. So as a result, active site density get reduced due to this some coalescence and merging of this bubble. And now in the second case, to obtain this bubble departure diameter, I have recorded these 500 photographs of the sitting surface were analyzed at this heat flux range. So at each heat flux, this bubble characteristic were captured for this zero point 0.7 seconds. So the bubble departure diameters varied with the applied heat inputs on the heating surface. So there will be the some properties of this refrigerant, that is the surface tension of this refrigerant R600A also affects this bubble size. So this experimental measured bubble departure diameter, this was also compared with this some correlations, most models, this is Jube. So same behavior that was detected for this up to this heat flux range 1 to 3, and above this level there is a some large deviation in the departure diameter was found due to this some experimental conditions. And then the third case, that is known as the departure frequency. So the number of the frames that was observing between these consecutive bubble departure at a given sites. So this process gives the frequency of the bubble departure. The number of the frames was considered between the 120 and 440 frames for 10 milliseconds to get this departure frequency. And average of this departure frequency was estimated at 4 active sites where the same bubble size considered. The frequency of this departure bubble is rapidly with increasing the heat flux with some predicted value of this is a Joubert. So the similar behavior between this predicted and present values of bubble departure frequency is observed for this R600. So according to this experimental boiling behavior is observed during this boiling of pool boiling of this R600A. So here we observe that this data basically it is predicted within the range of this plus minus 70%, and it gives this good agreement with this our experimental setups. And here this thermal performance of this refrigerant is increases with the increases the applied heat flux due to this some properties of this refrigerant. And also when we observe this boiling phenomena, so this predicted results is also satisfy this some present data of the experiment, and there will be the some deviation is also observed between these predicted because due to the some operating conditions or whatever this fluid condition is used. And here this liquid vapor exchange phenomena during the boiling is also visualized using this high speed camera arrangement, and this whatever this photo is captured during this whole boiling process, that can be analyzed, and according to this uh, analysis, we can say that this nucleus lumination site density varies with the increase of heat flux, and the variation of the departure diameter is also observed as we increase this heat flux, and the departure frequency that is also decreases with increasing the heat flux during the boiling over the plane heating surfaces. Thank you very much.
Thank you, Ashok sir.
Thank you, sir. Thank you very much.
Anyone from the audience? Any question? No, I don't think any question. I will ask some questions. I have some queries.
Okay.
First question is, mm, you say one preheater you have used.
Yes, sir.
Why? Preheater, what is the effect of that particular part?
So, sir, in these conditions, when these large vapor, or when there is a gas is formation inside this vessel, and we are not getting the actual temperature where we want to maintain inside this vessel. So in that case, firstly we use this preheater to supply the heat to the liquid. So in that case, we can control the saturation temperature of this liquid. Here we are maintaining the saturation temperature is the 12 degree centigrade.
Okay. What refrigerant you have used is 600A. Is it?
Sir, here we use the 600A.
Oh, you can specify how what is the practical use of 600A in our life, because there is some problem using that particular refrigerant. Is there any?
Yeah, yeah, yeah. In that case, there is only one problem is the flammability. But when we uh, choose this, when we go for this environmental impact, just low global warming,
No, no.
low,
I know that particular part, but is there any
but
practical only
this
flammability?
type of
Is there?
yeah, yeah, yeah. This type of refrigerant is largely used in the air conditioning plants. And nowadays, this we can see that in some AC is also using this R600A.
Okay.
But there is only one problem. That is the most important problem. That is the flammability. Only this problem is included in this condition.
So another thing is how the pressure has been controlled inside the cabin of that particular experimental part you have used. Pressure
So
how?
in that case we use the some chiller unit by supplying the water.
Achha,
So
cooling part.
by chiller unit, yeah, by using this chiller unit, we can control this pressure inside this vessels. So that chiller unit means here I have yeah, this one cooling circuits or this circuit. By using this circuit, we control this system pressure, whatever the system pressure we want.
Okay, okay.
So
What type of thermocouples you have used?
here I use this K-type thermocouple.
K type. Is there any difference of K type or T type if you use T type here?
Yeah, there is so many differences because there is some difference in the temperature. One is the temperature, another is the temperature range, another is the sensitivity.
Okay.
So as we have seen that in case of the T-type thermocouple, their diameter is a very small diameter is there. But in case of this boiling, when we fix this that thermocouple, so it will damage after some time. That's why I've used this K type of thermocouple, and its diameter is quietly larger than this T type of thermocouple.
Okay. 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 Now the last question is my query is actually I don't know how about that. How the bubble diameter you have calculated or measured?
this bubble, actually, I have captured this photograph from by using this high-speed camera,
Okay.
and by using this some analysis software. That software is known as image software.
Okay.
After
Okay.
analyzing, by using this software, we are able to capture this bubble size on the surface.
Okay.
So these are whatever the bubble size I have shown here, that is the average bubbles size on particular nucleus size.
Okay, sir. Okay, sir. Okay, sir. Okay. Thank you very much, sir. Thank you. Thank you.
Okay,
Thank you, sir.
thank you.
Okay. Now next. Thank you, Ashok Debangan, sir. Now, thank you.
Thank you,
Thank you,
sir.
sir.
Thank you.
Now next, 1558.
Yes, sir.
Devojit Roy, sir.
Yes, sir.
Are you there? Please start your presentation.
If my slides are visible,
Yes,
sir.
yes. Yes, yes. Now it's clear.
Uh,
Please start.
okay, sir. Good morning to all respected judges, and good morning to all participants present here. Myself, Devojit Roy, and at first I want to say thanks to Team ICTMA to give me the opportunity to present my work in front of you. My work title, a case study on thermoacoustic refrigeration system, and I have carried out this project when I was uh, as a UG student in JS College of Engineering. Now, presently, I am studying MTech in Jalpaiguri Government Engineering College, and it is basically an experimental work of constructing a cheap demonstrative model of thermoacoustic refrigeration system and doing an experiment by varying some parameters to observe to observe and evaluate the performance of this particular system. So my co-author was Dr. Sandeep Ghosh from JS College of Engineering and Suman Bhumik from JS College of Engineering. So here is the content of my presentation: introduction, thermoacoustic refrigeration cycle, components of the setup and experimental testing setup that I have made, and procedure and conclusion of future scope and references. So we all knew about the conventional refrigeration system, and my previous speaker has been said that the normal conventional refrigerant have some environmental issues, like the and they are they are coming with very much costly, and in there, if there is any leakage of refrigerants, it will be create health hazard situations. So researchers are going on to find a new conventional way of cooling nowadays, and in this area, the thermoacoustic refrigeration system has already got a significant mark and attention to the researchers. So thermoacoustic means basically operates by using sound waves and air or non-flammable gas mixtures in a resonating tube. So here is a thermoacoustic refrigeration cycle. Uh, if I if we consider a packet of gas which is moving from the left side to the right side in a resonating tube, and there is a stack. Stack is the medium on which mainly the temperature gradient takes place. So when the and here is the loudspeaker which acts as an acoustic driver, which gives the sound wave to propagate in the resonating tube. And in the resonating tube, I am using normal ambient air here. So as if we consider a packet of gas which are moving from right to left, and sound wave which are moving from left to right, and at a particular moment, sound wave done work on the packet of gas, and at the time of maximum compression, when the temperature of the packet of gas is increased, then the stack material, it loses its heat to the stack material. And the second part of the cycle, when the gas is returned to its initial state, the sound wave expands the gas, and at the condition of maximum expansion, when its temperature will be less than the stack material temperature, it receives the heat from the stack material. So this is the basic thermoacoustic refrigeration cycle. And literature review of thermoacoustic. So thermoacoustic induced oscillation was observed century before. The glass blowers are produced heat generated sound when blowing a hot bulb at the end of the cold nano tube. Brian Higgins first observed the heat energy conversion into sound wave, and one project is carried out by Naval Postgraduate School led by Steve Garrett, which have they are producing a space thermoacoustic refrigerator which have ability to move around about 50 watt of heat. And some students of mechanical engineering department of Ramakrishna Institute of Technology are given result about the varying above by varying the stack position in the resonating tube. And and T. Somasekar and P. Navin Kishore from Massachusetts Engineering College, Hyderabad, published a paper on IOSR-JMC on the thermoacoustic system and give results for frequency 80 Hertz, the temperature difference that they have achieved. So here is my components of setup. Stack is the most important component and can be say heart of the system. So I have used a paper made stack and aluminum foil made stack for my experiment. And here is the acoustic resonator. Acoustic resonator I have made, I have used is acrylic glass tube of 70 centimeter length and 5.7 centimeter of diameter. And one end of it I have attached with acoustic driver, and another end I have sealed it. Now amplifier, I have used normal amplifier of 10 hertz to 110 kilohertz of frequency band and 158 watt of power output. And digital thermometer I have used to measure the temperature difference in the stack. And working fluid, as I have said already, working fluid I have used in normal ambient air. And here is acoustic driver, normal loudspeaker I have used. So this is the total experimental setup that I have made. It is have two part house of loudspeaker which act as a acoustic driver, and resonating tube consists of house of gases. Here normally I have used ambient air and the hot and cold heat exchanger in the stack. So hot and exchanger, two sides of stack acts as a hot heat exchanger, and packet of gas is rejecting heat, and one is act as a cold heat exchanger where from where the gas receiving heat. So I have varied four frequency: 110, 135, 160, and 125 hertz. And I have very two stack material that I have already said that one is paper stack material and aluminum stack material. Three characteristics: sound wave character, sinusoidal nature, square nature, and triangular nature. And data are taken at a time span of 30 minutes, and this experiment thus gives results on various operational parameters. And I have given the frequencies by using one Android system called frequency generator. So here is the data that I have achieved for 110 hertz frequency for paper stack and aluminum foil stack for three type of nature of waves. And this is the temperature difference achieved on both two sides of the stack material. Here the data from 125 hertz frequencies, uh, similarly for paper stack and aluminum foil stack, and this is for 135 hertz frequencies data, and this is 160 hertz frequencies data similarly. So temperature drop in different frequencies and different nature of wave for paper stack that I have achieved. The peak temperature difference is obtained by sinusoidal wave of 125 hertz, and lowest temperature difference is obtained by square wave of 160 hertz. And triangular wave gives more consistent result in all those four frequencies. The triangular wave gives is more consistency result, and the square wave gives least temperature difference. I must say least temperature difference at all in all three natures. And this is the result obtaining by aluminum foil stack. Peak temperature difference is obtained by triangular wave of 125 hertz, and lowest temperature difference is obtained by square wave here also of 160 hertz, and triangular wave gives here also consistency in good results. So that we have seen that paper made stack material gives more better result because of paper stack material have uh, less thermal conductivity than aluminum foil stack. So we can achieve a good temperature gradient for paper stack, and it have given us a good result of good temperature gradient. Now, so we have done an experiment on the performance parameter by our apparatus made by us, and we can add some points here that paper stack is given good results than aluminum foil stack, and triangular wave give more consistency in result. But in peak temperature difference, I have achieved in sinusoidal wave of 125 hertz for paper stack material and triangular wave of 125 hertz in aluminum stack material. And working fluid that I have used is normal ambient air, but one can use lighter gases like inert gases, helium, neon. This for the experimental purpose, it will be better. And another factor that increase the efficiency of the system is proper sealing of the apparatus. If parts are not properly sealed, heat escapes from the refrigerator and it does not perform well actually. So in my setup, I have some leakage problem while doing my experiment on which we are working on. And the experimental parameters that I have written in my slide also can be increased. Experiment can be made with many more stack materials. Variation of the shape and the length of the resonating tube can be experimented, and use different frequencies range can be used in the experiment, and varying the position of the stack in the radiation tube, which I have written in my literature review that Sri Ramakrishna Institute of Technology students are doing. So one can done it also for their experiment, and the uses of inexpensive household items can be used to construct the refrigerator. So here is the references that I followed, and thank you very much. This is the end of from my session.
Okay, thank you, Devojit. Now,
Yes, sir.
any question from the audience? No, I don't think any question is there. So thank you very much, Devojit. Now
Sir,
next is 1559. Anyone is there for 1559? Energy analysis of vacuum dryer and vacuum freezer dryer for food and pharmaceutical application. TF 1559. No, no one. Next, TF 1567. Samir Kumar Anand.
Yes, sir. Yes, sir. Yes, sir.
You can start your presentation.
Okay, okay, sir. Sir, is my presentation visible? Sir, is my presentation visible?
Perfectly okay.
Okay.
Continue, please.
Good morning. Good morning, session chair, session co-chair, and session coordinator. And good morning to all of you. This is Samir Kumar Anand, MTech second year student from Jalpaiguri Government Engineering College, Jalpaiguri. The title of my presentation is a review and management aspects of reserves, production, consumption, quality, and life of coal of the world vis-a-vis India. So I have done this research under the guidance of Dr. Shopan Mitra sir, who is associate professor in Jalpaiguri Government Engineering College. So next slide. This is content. I will discuss all these things. Title of the presentation: abstract, introduction, coal reserves in world, coal reserves in India, production of coal in world, production of coal in India, consumption of coal in world and as well as in India, quality of coal in India, life of coal reserves of world and India in future, conclusion and references. Okay, title of the presentation that I have already discussed, a review and management aspects of reserves production, consumption, quality and life of coal of the world vis-a-vis India. So this is the abstract. So the aim of this research is to focus on proved coal reserves available in different countries of world along with different states of India. World's total proved reserves, production and consumption of coal are compared with India to find out its position in world. Qualities of coal reserves of India are also examined and coal life of both world and India are discussed. The management policy that may be adopted to use coal in better way considering environmental pollution are also discussed. Introduction. So coal is one of the most important non-renewable sources of energy in world. Energy is one of the most vital building blocks in human development and a key factor influence the sustainable development of any nation. So I can not go through every point because there is a limited time. So I will only discuss some important points only. So you can see third point that 90.8% of total coal reserves are found in top 10 countries of the world only. The United States is leading in proved coal reserves with share of 23.7%. You can see by table here you can see the top 10 countries having highest proved coal reserves at the end of 2018. You can see on the top United States is on the top in terms of coal reserves in world and India is on fifth position. You can see some other countries in the list that is the top 10 countries, and in this table you can see R by P ratio is also given and this is the life of the coal reserves, and we have divided into subsections anthracite and bituminous, and another one is subbituminous and lignite. Next slide. Okay, you can see region wise percentage distribution of proved coal reserves in world in 2018, and you can see Asia Pacific is having the highest coal reserves in the world with share of 42.2%, and other than this North America is 24.4%, and some other regions are also been seen in this pictograph. Next slide. Okay, coal reserves in India. According to Geological Survey of India, India has 3,26,495.63 million tons of coal as on 1st April 2019. Coal reserves are found in 15 states of India. Jharkhand has proved coal reserves of 48,031.93 million tons, which is leading state in India with share of 30.86. And you can see that the major proved coal reserves are found in the state of Jharkhand, Odisha, Chhattisgarh, West Bengal, Madhya Pradesh, Telangana, and Madhya Pradesh. Okay, you can see here the category wise coal resources indicating augmentation, and you can see here blue strip shows as on 1st April 2019 and brown strip shows as on 1st April 2018. This is the comparative study, and you can see that in 2019 there was comparatively higher in terms of proved, indicated, and total, and in case of inferred, it is comparatively the same. Now you can see coal reserves in India. You can see state-wise distribution of coal in India. You can see here Jharkhand is on the top, Odisha, Madhya Pradesh, West Bengal. You can see West Bengal is on the fourth position in terms of coal reserves in India. Now the production of coal in world, like random distribution of coal reserves in world, coal are also randomly produced in different countries and region and countries of the world. China is the leading coal producer country in the world with share of 46.7%. This is a big data. You can see here that around 50% of the coal are produced by China. And the top 10 countries of the world produced 93.2% of the total coal produced in the world, and remaining countries produced only 6.8% of the total coal produced in the 2018. This is the big data of my research, that top 10 countries 93% coal were produced by top 10 countries. You can see in the table that top 10 coal producer countries in year 2018 which is rank wise arranged. You can see China is on top, that I have already discussed, with a share of 46.7%. I have given here data of 2015, 16, 17, and 18. So India is on fourth position, and some other countries are also available here: United States, Indonesia, Australia, Russia, South Africa. These are the some countries, top 10 countries of the world in terms of production of coal reserves in world. Okay, this is the region wise uh, percentage distribution of coal reserves in world in 2018. Once again here, uh, Asia Pacific is having the highest production, 72.8%, and North America having 10.2%, and other some other regions are also here discussed. Okay, production of coal in India. Asia Pacific produced 72.8% of the total coal produced in 2018. India is a fourth leading coal producer country with share of 7.9% of the total coal produced in 2018. India is continuously increasing its coal production year by year. Okay, consumption of coal in world. Asia Pacific consumed more million tons of oil equivalent of coal than they produced in 2018. Asia Pacific is leading coal consumer with share of 75.3% of the total million tons of oil equivalent of coal consumed in 2018. Okay, you can see here top 10 coal consumer countries in 2018 rank wise. Once again, you can see, you have seen in the previous slide that China was the top coal producer country, and here top consumer country also. You can see around 50% of the coal consumed in world were consumed by China, and India is the second on the list of second, and is on third United States, and some other countries are also discussed here with its share. Okay, this is the region wise percentage distribution of coal consumers in world in 2018. Once again, Asia Pacific is on the top, that is 75.3%, and other than this, North America is on 9.1%. Okay, this is the consumption of coal in India. India is the second highest coal consumer country in world with share of 12% of total coal consumed in 2018. Due to one of the fastest growing economy, India is continuously consuming more million tons of oil equivalent of coal in subsequent year for satisfying country's need. Okay, yeah, you can see here the quality of coal in India. Indian coal is degrading day by day. Most of the coal now available for power plants contain approximately 40% of 40% or more as coupled with 10% moisture. Good quality coals are mostly supplied to iron and steel and some other specific industries. Here you can see quality of coal in India. You can see the highest percentage is inferior non-coking, that is 68.82%, and this shows that comparatively India's coal is relatively poor, and having sulfur, prime coking, medium coking, semi coking. These are the qualities of the coal in India with its percentage. Okay, now this is the life of coal reserves of world in future. Now this was found by the formula life in years is equal to available coal reserves in last year divided by production of coal in last year, and according to this formula the life of the world in future was found to be 132 years. Now in case of India, it was found to be same, using the same formula. Now, coming to the conclusion of my research. From the foregoing review and analysis, following conclusions and comment may be made. More than 90% of coal reserves are found in top 10 countries of the world. Similarly, nearly 95% of the total proved coal reserves are found in top 10 states of India. This clearly shows uneven or random distribution of coal reserves in different countries of the world as well as in different states of India. This uneven distribution sometimes causes concern of timely availability of coal, and it is found that sometimes supply chain is broken down, causing production loss in distant states from mines. The contribution of India in total proved coal reserves is good and having share of 9.6% and hold fifth position in the world. Globally, India is fourth leading coal producer country with share of 7.9% of the total coal produced and second leading coal consumer country with share of 12% of the total coal consumed in 2018. In India, coal quality is degrading day by day. In fact, India has 68.82% of inferior non-coking coal. Thus, India's coal quality is comparatively poor. Based on available proved coal reserves and current production in India, as well as in world, coal reserves of world and India comes out same. That is about 132 a year. For energy security and sustainable development point of view, India should very seriously focus on alternative sources of energy. And this is the very important point of my paper that we should seriously focus on alternative sources of energy, especially renewable sources of energy such as solar energy, wind energy, small hydro energy, and bioenergy. Coal causes pollution in huge quantities, which is very unsafe for environment and health. These pollution are major cause of serious global environmental issues. That is global warming, ozone layer depletion, climate change, and acid rain. These are the major problem of India as well as world this time. The coal available in power plant are properly conducive in many cases for good efficient burning and leads to much pollution. Imported good quality coal is mixed with the local coal and used in power plant. Now, to address just above two issues, the following management aspects or policy may be adopted. First is emphasis should be given to reduce coal as a fuel in power plant. Instead of coal, focus should be concentrated on environment friendly energy sources like renewable energy sources. International practice of washing coal before use should be meticulously followed. High taxes should be imposed on non-performing plants in respect of pollution norms. Proper pollution reduction equipment such as electrostatic precipitator or air cleaner should be used. Burning of present poor quality available coal for power plant leads to much efficiency loss and pollution. So new technology should be devised where coal particles will get more residence time to burn, and also burning should be take place at lower temperature, which will result in higher efficiency and lower pollution. In this respect, focus should be given to build as much as possible supercritical boiler, particularly FBC and PFBC. And last one is old power plants should either be properly renovated or dismantled from pollution regions and to enhance efficiency, and thereby fuel requirement will be less. So these are the references that I have used, and thank you.
Thank you very much.
Thank you, sir.
Now my question is,
Yes, sir.
you are from Jalpaiguri Government Engineering College.
Yes, sir.
Which year?
Second year.
Is there any guide you followed?
Yes, sir. Dr. S. Mitra, sir.
Who?
Dr. Chopin Mitra, sir.
Shobhan Mitra sir. Achha. Now my question is, which subject actually related to this particular part?
Sir, energy management.
Energy management. So, can you show any mathematical data?
Sir, only single mathematical data that is I have used for finding out the life of coal reserves, coal of world as well as India.
Show it.
Yes, this is the equation, sir. Life in years is equal to available coal reserves in last year divided by production of coal in last year.
Okay.
Sir, I have one question.
Yes, sir.
Yes, please.
Sir, Mr. Samir, actually you are in MTech or BTech?
MTech.
Student of Jalpaiguri or BTech?
Jalpaiguri, sir. MTech. MTech student in Jalpaiguri Government Engineering College.
I want to suggest you that you have put so many references, so many conclusions. So conclusion is not like that. You have put 3 pages conclusion. Conclusion is actually, it is my suggestion that when you write good papers, no, you have to follow certain norms. So conclusion is not like that. As I am the alumni of this college, so I will definitely want you to shine in life. So one thing I want that I have seen that so many in the last you have put, there were 3 pages of conclusion. The conclusion should be in gist form. Okay,
Yes.
so please,
Okay, sir. Okay, sir.
you have
Now,
given
okay.
work? Did you visit any case study? Went to, you could have gone to some coal India, you have visited some mines. What is the reason for this ash content? I myself have worked in a large area in coal area in WCL, Western Coal.
Yes, sir.
So I have vast experience in this. So what is the reason? I have one question. What is the reason behind this high ash content? You could have explored this type of things.
Sir, repeat, sir.
To
Please
understand
repeat.
the question. What is the reason behind this ash percentage? You have mentioned in one of the slides, ash percentage is very high. Did you did some work? Did you went to some coal field?
No, no, sir. Actually, my research is related that actually the main problem of the world as well as India is that
No,
we
you have,
are
this is a
we are
review paper. No, this is a review paper. Means you have collected data from
yes,
the
sir. Yes, sir.
uh, different sources. But
Yes, sir. Yes, sir.
my suggestion is that you have done it yourself. So this could have been got from the internet also. You could have, I could have gone from, but you, it is your work. It is your work. When you present your work, you could have presented your particular way of
Yes, sir.
presenting it. Okay,
Yes, sir.
my suggestion. This is my just suggestion.
Okay, sir.
Uh, it's okay. Now,
Thank you,
my
sir.
option is my question and suggestion is also for you that
Yes, sir.
whenever you study some anything related, you must first find your way in the sense your purpose of researching on that particular subject. I
Yes,
don't
sir.
know what would be the purpose of researching such particular in second year you are, but you never give actually the never put the actual data.
Yes, sir.
So only theoretical data are there, and all are searching from the internet, I think. So that would be not a good idea, you know.
Yes, sir.
So study on that. Okay, best of luck for your future.
Sir,
Thank you.
one thing, sir. Sir, 1 second. Sir,
Yes.
you have asked about why you have done research like that. What was the purpose of this research?
Yes.
Sir,
Yes.
actually, I want to tell you that this research is mainly focusing on the that we have limited non-renewable sources of energy, and what are the at the present consumption rate and production rate, what will be the future of India and world? Another along with this, I have focused on that what kind of pollution and what are the things that occurs due to the non-renewable sources, like we have used coal and lots of pollution are causing, and due to this the very large amount of pollution are created, and many problems like acid rain, ozone layer depletion, and these are happening. So main focus was that and that to understand uh, understand these things, and uh, very serious we should very serious for future perspectives.
It's okay, but the study, the way you have studied, that
Yes, sir.
not much up to the date actually. You have to learn more on that particular.
Okay.
Okay, okay, it's okay. You have time in future. You will do it.
Yes, sir.
Okay, best of luck. Best of luck. Thank you.
Thank
Thank
you,
you.
sir.
Thank
Thank you,
you.
sir.
Okay. Now the next one is 1569. Mr. Tripuresh Dev Singha. Are you here?
Yes, sir. Yes, sir. I
Yes,
am
yes.
here.
Yes, please start your presentation. Thank you.
Sir, is it visible to all of you, sir? Sir, is it visible? Sir, is it visible? Sir, is it visible?
It's visible. It's visible to us.
Okay, sir. Sir, can I start?
Start.
Sir, am I audible?
Yes, audible. Thank you. Continue.
Good morning to all of you. Sir, I am Tripura Singh, Assistant Professor of Government College of Engineering and Textile Technology, Shirampur. So, I will be presenting on the topic low velocity impact analysis of pre-twisted composite sandwich conical shells in hydrothermal environment. So, in my topic, these contents are there: introduction part, then literature reviews, problem definition, mathematical formulation, results and discussions, conclusions, and some references. As you know, the sandwich structure is a special type of composite structure, multi-layered composite structure, in which typically two facings are joined together with a light compliant core in the middle by adhesives. The main purpose of the sandwich construction is to make the light structure, which are used mainly in the aircraft applications. Not only the aircraft applications, but also the different components in the windmills, particularly the windmill blades, naval ships, and also the turbo machineries applications. And but these structures are frequently subjected to the different types of loadings. The loading may be the static loading, the loading may be the dynamic loading. So one of the dynamic loading is the low velocity impact. The impact may be the high velocity impact, but the low velocity impact are dangerous as the due to its effect on the material on which it is impacted. And also the low velocity impact causes the different type of breakage, like the fiber breakage and matrix cracks of the composites, which are not visible from the outside. So these are but it can be detectable. And also the low velocity impact causes the debonding between the face sheets and the cores, which are very dangerous for particularly different components, particularly used in the aerospace applications, aircraft application, where the damage may cause the catastrophic failure of the different components. And the impact may be the normal impact or oblique impact. Generally, the oblique impact are more common. It is not possible, or that the 90-degree to the surface impact of the of anybody 90-degree to the surface, it is not always possible. The impact may be the oblique. And impact are very common when any foreign objects colliding with the helmet, when when a man riding the bike and the hailstone impacting on the roof of the house, or the different components, and the runway debris impacting on the aircraft wings, fuselage of the aircraft, and the collision of the two vehicles. So these are or any tools dropping on the during the transportation, dropping on a surface. So these are very common. That is the impact occurring during the practice. So there are wide investigations carried out on the low velocity impact and high velocity impact. The several literatures are available, but only few literatures are considered here for some specific, like the Birman and Cardometius reviewed the modern trends and theoretical developments and novel design of the applications of the sandwich structure. And this sandwich may be the composite sandwich, this sandwich may be the functionally graded material sandwich. And then and one of the oldest work on the low velocity impact on the composite material using the finite element method was carried out by Sun and Chen in 1985. And they showed the different transient responses of the low velocity impact and different parametric studies. Sai and Ju reviewed the past and current research progress on the dynamic response of composite sandwich structure subjected to low velocity impact in 2011. And one of the recent work by Bandyopadhyay and Karmakar, the hygrothermal effect, that means the effect of temperature and the moisture on the low velocity response of the delaminated composite conical shells. They showed the effect of the moist environment and the hot environment on the different parametric studies. And it is seen that in the literatures there are very limited works done on the low velocity impact on the sandwich construction, particularly in the hygrothermal environment. So that is why in that work we mainly study the finite element. Finite element formulation is to be developed using the first order shear deformation theory, very popular structural theory. And the various parametric studies are done, particularly the time histories of the contact force and the central shear displacement will be studied. Sir, am I audible? Sir, am I audible? Sir, am I audible? Sir, am I audible?
Yes, you are audible.
Sir, am I audible?
Yes, you are audible.
Actually, here the network is very poor. That is why I am repeating, asking you that whether I am audible or not. Okay, sir. Thank you. And in this study, the shallow conical shell is considered. Here it is shown that the conical shell panel is obtained by truncating the conical shell, whose length is S and the span length is L. The base subtended angle is phi 0. The vertex angle is phi V, and P0 and Q0 are the minor and major radii of the oval cross section at base. Now the sandwich conical shell panel is obtained from this conical shell, and here the thickness, the different layers of the sandwich shells are shown here. The top face sheet and bottom face sheet both are 5 layered composites, and the core is the foam core. And HC and HF are the thickness of the face sheet and the thickness of the core, and H is the thickness. And here the conical shell panel is considered as a cantilever. That means one end is fixed and other end is free. And the orientation of the fibers in the composites are 0, 90, 0, 90, 0 in the top face sheet, and similarly in the bottom face sheet. And here the steel ball, that means which is known as the impactor. The impactor is impacted on this conical shell, sandwich conical shell, normal in a normal direction, the perpendicular to this shell at its central point. The pre-twist radius and the radius of the conical shell are related with the angle of twist. That means the shell is twisted, angle of twist, and the radii of the major and minor radii, that means P and Q of any oval cross section across the along the length of this shell, where P and Q are related with the phi V, that means the base subtended angle, and phi 0, that means the vertex angle and base subtended angle, the cone length, and B0 means the width of the conical shell panel at its fixed end by these relations. Now, due to the normal impact on the conical shell by the steel impactor, that means the elastic impactor, with the initial velocity vi. So this is the system before the impact. That means the shell, this is the shell structure. So it is impacted on this shell, and after the impact, so there is a local indentation occurs. So local indentation here is considered as A, and the local indentation is computed by this formula. That means Wi minus Wp cos phi. Wi is the displacement along the z direction of the impactor, and Wp is the displacement of the mid plane of the shell along the z direction. Now the kinematic condition of the shell displacement are determined using the first order shear deformation theory, very popular structural theory, first order shear deformation theory. That means FSDT. U, V and W in X, Y and Z directions are the displacement components at any point within the shell. So these are related with the displacement components of the mid plane U0, V0 and W0, and theta x and theta y, where theta x and theta y are the rotations of the normal to the mid surface plane about y and z directions. Now the linear strain components are determined from these displacement components by using this formula, where epsilon 0 are basically the mid plane displacement, mid plane strain are related with the mid plane displacement components U0, V0, W0 by using this formula. And at the same time, the nonlinear strain components are nonlinear strain basically induced due to the hygrothermal effect, due to the moisture and temperature effect. So nonlinear strain component epsilon NL are determined by using this formula. That means are related with the U, V, W, Ry, Rxy. Ry is the radius of the curvature of the conical shell in y direction, and Rxy are the radius of twist. Now the hygrothermoelastic constitutive equation, that means the stress strain relationship in the hygrothermal environment, are related with by this formula, where sigma are the components of the stress, and Q bar Ij are the reduced off axis reduced elastic constants, epsilon are the strain components, alpha are the coefficient of thermal expansion, beta are the coefficient of moisture expansion, and delta T is the change in temperature. That means delta T equal to T minus T0. T actually, T is the temperature at any temperature, T0 is the reference temperature, and delta C is the change in moisture concentration. That means C minus C0. C is the concentration, any concentration, and C0 is the reference concentration. So generally T0 is considered here 300 Kelvin and C is considered as the 0%. And the off-axis reduced elastic constants Qij bar are calculated using this formula, this formula in a matrix form, where M is equal to cos theta and N equal to sin theta. Theta is the orientation of the fiber. So as fiber of the facings, as the facings are the composites, as we know, the composites here, the fiber reinforced composite are obtained by orienting the fibers along its length in a polymeric matrix. And Q are the on axis reduced stiffness coefficient, which are calculated from the Young's modulus, the rigidity modulus, etc. Now this analysis is carried out by the finite using the finite element formulation, So as the conical shell, cantilevered conical shell, the planform of the conical shell is the trapezoidal, and this trapezoidal planform of the conical shell is discretized into some number of elements, and each and every element here considered as a isoparametric shell element with 5 degrees of freedom per node. So out of 5 degrees of freedom, that means U0, V0, W0, these three are the linear displacement, and theta x and theta y are the rotational degrees of freedom. So here 8 noded isoparametric shell elements are considered with the local natural coordinates xi and eta, and using this isoparametric formulation, the mid-plane displacement components are determined in terms of the shape functions matrix, that means the ni, using this formula. So delta is the mid-plane displacement components, and delta ei is the nodal displacement components, are related by these formulas. Now the kinetic energy is calculated for element using this formula, that means a TKE, using this, that means it is basically equal half into mv square, and after reducing this formula, ultimately we get half into delta transpose me delta E, where the me is basically the elemental mass matrix, and the elemental potential energy is calculated due to the linear strain components is calculated using this formula, that means half into epsilon transpose into sigma. Ultimately we will get half into delta into ke into delta transpose into ke into delta, where ke is the elemental elastic stiffness matrix, which is calculated which is related to the B matrix, D matrix, and B matrix. That means B matrix is a stress displacement matrix, D is the elastic matrix, and J is the Jacobian. And elemental potential energy due to the initial stress arising out the hydrothermal effect is calculated using this formula, where the epsilon NL is the nonlinear strain components, already I have mentioned, and sigma 0 HT is the initial stress vectors due to the hydrothermal effect. As ultimately we will get the half into delta E K sigma E HT delta E, that where the K sigma E HT is the geometrical stiffness matrix for the element due to hydrothermal effect. And ultimately using the Lagrange's equation, we will get the dynamic equilibrium equation for this impactor and the shell system, where M is the global mass matrix, delta is the vector which contains the global displacement, and K is the global stiffness matrix. K sigma HT is the geometric stiffness matrix due to the hydrothermal effect. FHT is the global hydrothermal effect, and FC is the contact force vector, which is calculated, which can be expressed by this formula, where FCI is the contact force of the ith node at which the impact actually commences. The dynamic equilibrium equation for the impactor is derived using this formula, where Mi is the mass of the impactor, delta I dot dot is the acceleration, and Fc is the contact force vector. And the contact due to the impact, the contact force due to the impact is calculated by modified Hertzian contact law. That means the contact force Fc is proportional the modified stiffness contact stiffness can be calculated using this formula, where EI is the Young's modulus of the impactor, E2 is the Young's modulus of the face sheet on which the impactor is impacted, and Ri is the radius of the impactor. And so this impact force is calculated for the loading cycle. So as we know, when a impactor is impacted on a surface, so first the loading during the movement, forward movement, and during the reverse movement it is unloading, and again forward movement it is reloading. So three different cycles are considered. So for the loading cycle, it is calculated FC equal to Kc a to the power 1.5. Then for the unloading and reloading cycles, the FC are calculated by this formula, where A0 is the permanent indentation, AM is the maximum indentation, and FM is the maximum contact force during the cycle. Now we have validated our formulation with various examples, out of which I just only here I am presenting only one important validation part, and I have considered one example. So that means the low velocity impact on a composite plate, as it is done by Shen and Shen in 1985. So here the results of the Shan and Shen and the results from our finite element method were calculated. So we have considered here actually the plate of size 20 centimeter with 20 centimeter and thickness equal to 0.269 centimeter.
What happened? Tripudesh. I think link has gone. We'll wait for 2 minutes. So we have to conclude it. I don't think anyone more is there. Thank you for the session.